you What's up, everybody? We are back for day 4 of the AWS Cloud Quest. I'm your host, Davin Jackson, DJax, Jax, D, whatever. But we are streaming live from the Alpha Esports and Technology Center here in Swanee, Georgia. For those who are new here, thanks for tuning in. We are doing the AWS Cloud Quest, which is a game that helps you learn the AWS Cloud Practitioner certification. Now, we previously held this cert, and we're using it now to recertify. And so far, we've done three different classes or 3 different parts of the AWS. Hold on, what can connect the user through SSH shell? Oh, come on. No, don't run away. All right. Well, I did it wrong. Anyway, so we do we try to do a mission or 2 every day, and until we get to the end of the course. I think we'll probably do a couple today, depending on how long it goes. But if you are new here, you can also take this time to ask me any questions. We can talk about just about anything. Again, we are here at the Alpha Esports and Technology Center, which is our esports gaming and tech education center here in Georgia. And like I said, if you don't know me from that, you may know me from my work and things I've done in cybersecurity. So I've also hosted shows like InfoSec Unplugged and Hacker Valley Blue. I have 2 LinkedIn courses on API security. I've taught several classes, done several talks and presentations. So like I said, we're just kind of doing this here to kind of go through this. Figured it would be cool to do something with tech in a gamified sense, since that's kind of what we like to promote here at Alpha Esports and Technology, with different ways of learning. And like I said, if you like what you see, you can be sure to please like the page wherever you're watching, because we are streaming on multiple platforms thanks to LinkedIn. So we are on YouTube, Twitch, Facebook, and LinkedIn. So wherever you're watching, please be sure to like, follow, subscribe. If you're on YouTube, you can click the bell for notifications so you can be notified when we go live. And also just let me know what you're thinking here in the comment section, or leave a message in the chat and I will get back to you as soon as possible. Again, we're streaming live, so I will answer the questions live. And like I said, we can just hang out while we go through these. Okay. All right. So now we found our next client on our AWS island, and it looks like it's covering networking concepts. So it says, welcome to our headquarters, so glad you came to help. Can you help us solve our VPC connectivity issues? I feel like, okay, sorry. All right, so we'll go ahead and connect to that. Again, so we're going to learn about EC2 again, just AWS overall, and then VPC. So we'll start with the videos, and then we'll just kind of go through. Okay, so let's check out the AWS Global Infrastructure. I think a lot of the
AWS Global Infrastructure Overview.
Just watch again.
The AWS Global Infrastructure delivers a cloud infrastructure companies can depend on, no matter their size, changing needs, or challenges. It is designed and built to deliver the most flexible, reliable, scalable, and secure cloud computing environment, with the highest quality global network performance available today. AWS provides the most extensive global footprint to ensure your worldwide customers are served. You can rapidly expand operations to virtually any region or country. AWS now spans 69 availability zones within 22 geographic regions around the world. The footprint is expanding continuously, with plans for 13 more availability zones, and 4 more AWS regions in Indonesia, Italy, South Africa, and Spain. This fast-paced expansion of region is also paired with Amazon's long-term commitment to a sustained future, using renewable energy sources. The AWS Global Infrastructure consists of the following main components. Amazon Cloud Computing resources are hosted in multiple worldwide locations, referred as AWS regions. Each AWS region is a separate geographic area and has multiple, isolated locations known as availability zones. A AWS region has at least 2 availability zones, most have 3, including all new regions, and several have as many as 6. They are fully isolated and are many kilometers apart from each other for complete redundancy. Each availability zone consists of 1 or more discrete data centers, typically 3, and at full scale can be hundreds of thousands of servers. To ensure maximum reliability, each data center has redundant power, dedicated metro fiber connectivity, and housed in separate facilities. Network. Every data center, AZ and AWS region is interconnected via a purpose-built, highly available, and low-latency private global network infrastructure. The network is built on a global, fully redundant, parallel 100 gigabit Ethernet metro fiber network. Points of presence. With Amazon CloudFront, AWS operates the largest global content delivery network, CDN, of any cloud provider. It enables customers to securely deliver customers' data content to end users with lower latency and high transfer speeds through a worldwide network of global points of presence, POP, locations, which consists of edge locations and regional edge cache servers. Availability zones make partitioning
What's going
applications
on,
as
Tam? How you
easy
doing?
as it can be.
Thanks for joining. We're just
If
doing
an application is partitioned
continuing with
across
our
availability
AWS
zones,
Cloud Quest
companies are better protected from natural disasters such as lightning
training.
strikes, tornadoes,
So
earthquakes.
they pretty much made a game out of
In this
AWS
example,
training
you can deploy your application
to
across
certify or
3 availability
recertify
zones, and a
your
load
AWS
balancer is used to
certification.
distribute
So we
traffic
figured
across them.
we take some time out and
If one
prove it.
availability zone experiences an outage,
Since we have a
traffic
gaming
is routed
center,
to
we
other
want to kind of
availability
show the
zone.
different types of
Customer application
ways
is
you
still
can
up
learn.
and running.
All right, so we did that. Like I said, I wanted to
AWS Global Infrastructure benefits. Here are the benefits of the AWS Global Infrastructure. Performance. AWS Global Infrastructure ensures high quality and uninterrupted performance. It offers customers a high-performing, low-latency, highly scalable, high-availability, secure cloud infrastructure and responds to changing needs fast without any drop in performance. AWS provides customers with the highest levels of availability and reliability. AWS availability zones are designed for physical redundancy and provide resilience, enabling uninterrupted performance with no single points of failure. Every component of the AWS infrastructure is designed and built for redundancy and reliability, from regions to networking links to load balancers to routers and firmware. In addition, the AWS Global Infrastructure is built on Amazon's own custom hardware, such as custom purpose-built compute servers, load balancers, routers, and silicon. AWS optimizes this hardware for only one set of requirements: workloads run by AWS customers. By using custom hardware, AWS provides customers with the highest levels of reliability, the fastest pace of innovation, all at the lowest possible cost. Security. Our core infrastructure is designed to meet the most stringent security requirements in the world and is built to satisfy the security requirements for military, global banks, and other high-sensitivity organizations. Our infrastructure is monitored 24/7 to help ensure the confidentiality, integrity, and availability of our customers' data. Scalability. The AWS Global Infrastructure enables companies to be extremely flexible and take advantage of the conceptually infinite scalability of the cloud. Customers can provision the amount of resources that they actually need, knowing they can instantly scale up or down along with the needs of their business. Companies can quickly spin up resources as they need them, deploying hundreds or even thousands of servers in minutes. Low cost. With the industry's most extensive data center footprint, the AWS Global Infrastructure enables more customers to benefit from cloud economics of scale and reduce the total cost of ownership, TCO, of their overall IT infrastructure.
One second, y'all. All right, where are we? Okay, so we talked about the infrastructure. All right, let's just do the VPC overview.
Amazon Virtual Private Cloud, VPC overview.
Like I said, I think
Amazon
we covered a lot of
Virtual
these,
Private Cloud.
but
Amazon
and it's
VPC
interesting because there's a
is like
couple
your
of these
own
that I'm
private
pretty
cloud within
sure
the AWS cloud.
I answered
It
them
lets you
properly
provision a logically
on
isolated
those
section of the
tech quizzes
AWS
that we were
cloud,
doing
where
last
you can
week.
launch AWS resources
So,
in a virtual network that you define.
especially when they were talking about
This
the
is a virtual
availability zones
network
and how many
dedicated to your AWS
availability
account.
zones you could have
Alternatively,
in a
your
region.
AWS account comes with a pre-configured default VPC in each region. You can launch your resources into the default VPC right away. Amazon VPC also provides you with complete control over your virtual networking environment, including selection of your own IP address range, creation of subnets, and configuration of route tables and network gateways. To get started with creating a VPC, you must assign it with a range of private IP addresses. Amazon VPC supports IPv4 and IPv6. Your resources can communicate over IPv4 or IPv6 or both. By default, it uses the IPv4 addressing protocol. You can also bring your own IP prefixes. A VPC spans all of the availability zones in the region. After creating a VPC, you can add one or more subnets in each availability zone. A subnet is a partition of a VPC's IP address range. For example, your VPC has a total of 1024 IP addresses, and you configure 4 subnets, Each has 251 IP addresses. Each subnet must reside entirely within one availability zone. You can launch instances into subnets in multiple availability zones to improve fault tolerance and hence, building highly available applications. Creating multiple VPCs is supported. In one AWS account, you can create up to 5 VPCs per region by default. If more is required, this limit can be increased through AWS support. Now, let's talk about the key benefits of Amazon VPC. First, it is simple. Using the AWS Management Console, VPC can be quickly and easily created. You spend less time setting up and managing, so you can concentrate on building the applications that run in your VPCs. Customizable. You can easily customize the network configuration of your Amazon VPC. For example, you can create a public-facing subnet for your web servers that have access to the internet. You can also place your back-end systems, such as databases or application servers, in a private-facing subnet with no internet access. When you configure VPC to connect to your corporate network, it can serve as an extension of your own data center. In addition, VPC can also be connected to other VPCs. Secure. Amazon VPC provides multiple layer of advanced security features, such as network access control lists, NOCLs, and security groups, to enable inbound and outbound filtering at the subnet and instance level. In addition, you can store data in Amazon S3 and restrict access, so that it's only accessible from instances inside your VPC.
Sorry, y'all. Again, just doing a little bit of multitasking here. All right. Okay, so we talked about the VPCs, that they're customizable, allows you to spin them up as quick as possible. You do have security groups that allow you to create access control lists. They connect to your Amazon S3 buckets, which is your storage for your container for your data. Okay.
Amazon Virtual Private Cloud, VPC Internet Connectivity. An Internet gateway is horizontally
Calvin, how you
scaled,
doing?
redundant, and highly available by default. It allows communication between your
doing a little bit of
VPC and the
training.
Internet.
Figured I'd stream it since they kind of made it in a
supports both
gamified.
IPv4 and IPv6
They
traffic.
put it in a gamified
To enable
version
Internet
of it,
access for
and
instances in a VPC
we have a
subnet,
gaming
you
and tech
must
center.
attach
So
an
what better
Internet
way to
gateway
put
to your
together?
VPC. Add a route to your subnet's route table and point your route table to the Internet gateway. Make sure your instances have public IPv4 address, IPv6 address, or elastic IP address. An elastic IP address is a static public IPv4 address. Static means it does not change over time. You can rapidly move an elastic IP address from one instance or network interface to another. Lastly, ensure that your network access control lists, NOCLs, and security groups allow the relevant traffic to flow to and from your instance. On the other hand, you need a NAT gateway in the public subnet to enable instances in a private subnet to connect to the Internet, but prevent the Internet from initiating connections with the instances. NAT stands for Network Address Translation. When traffic goes to the Internet, the source IPv4 address in the private subnet is translated to the NAT gateway's address at the public subnet. Similarly, for the response traffic, the NAT gateway translates the address back to the instance's private IPv4 address. To create a NAT gateway, you must specify the public subnet in which the NAT gateway should reside. You must also specify an elastic IP address to associate with the NAT gateway when you create it. After you've created a NAT gateway, you must
like
update your
everything
route
wants to
table for your
go-
private subnet to point Internet
Everything wants to
traffic to the
happen the
NAT
moment
gateway.
you start streaming.
Note that
Start
NAT
doing
gateways are
whatever.
not supported for
Calvin,
IPv6
if you go
traffic.
to
For
cloudquest.skillbuilder.aws,
IPv6 traffic, you would use an egress-only Internet gateway
or
instead.
just Google AWS
This allows
Skill Builder.
outbound
For me,
communication
they
over
gave me this option
IPv6 from
because
instances
I
in your
had to recertify
VPC to the
anyway.
Internet. At the same time,
But I
it
don't
also
know if
prevents
they have it,
resources on the Internet
just
from
starting
initiating
out, so.
communication with your instance directly. An egress-only Internet gateway is stateful. It forwards traffic from the instances in the private subnet to the Internet, and then sends the response back to the instances. To route traffic from instances in your private subnet to the internet, you would need to add a route in the route table and point all internet-bound IPv6 traffic to an egress-only internet gateway.
Okay, let's go.
Amazon Virtual Private Cloud, VPC concepts. The following are some of the key concepts for VPCs. When you create a VPC, you must specify a range of private IP addresses for the VPC, in the form of a classless interdomain routing, CIDR block notation. The allowed CIDR block size is between a /16 and /28. For example, this IPv4 CIDR block, 10.0.0.0/16 notation, when you write this out in 32 bits binary, you get the following. The number followed the slash symbol, in this case, 16, means that the first 16 bits remains fixed. And you can vary the next 16 bits, providing you with a total of 65,536 IP address
for the cloud
A
practitioner.
CIDR block
Like
of
I said, I already have my cloud practitioner certification, so
0.0.0/0 would
I
allow
believe after
access to any
taking
IP address.
this and doing
To the
the
original
hands-on
primary
stuff,
CIDR
it'll allow
block,
me to
you can assign
recertify.
additional private IP addresses, a secondary CIDR block, to expand your VPC. Private IP addresses are local addresses in your VPC. They are not reachable over the internet. They are used for communication between the instances in your VPC. To connect to your instance over the internet, you can assign a globally unique, public IP4 address to your instance. On the other
And
hand,
don't quote me on it, but
IPv6 addresses are public
it looks like
and
they
reachable
have
over the internet.
they have
When you create a
versions of
VPC
this for
with
the
CIDR
other
block,
certifications
such as
as well.
10.0.0.0/16,
I could be wrong,
note that
but
you will not
like I
have
said,
all
that's what it looked like to me.
65,536 IP addresses.
Because
It is because 5 IP addresses are reserved by AWS for internal
So there's a
use.
serverless island,
To
there's
create
an
more
AI
than one subnet in
island.
your VPC, make sure that the CIDR blocks do not overlap. That's why we
So
specify
it makes me think
10.0.10.0
that
and
there's
10.0.20.0 for the two
they
subnets.
have other islands with more missions to
/24
help prepare
indicates
you
assigning
for
251
other parts
IP
of
addresses for the
other
subnet.
certs with AWS.
When you create a VPC, it automatically has a main route table by default. You can also create your custom route tables. A route table contains a set of rules, called routes, that are used to determine where network traffic is directed. Each route in a table specifies a destination and a target. This main route table shows a local route that enables communication for all resources within this VPC. Each subnet in your VPC must be associated with a route table. You use a public subnet for resources that must be connected to the internet, and a private subnet for resources that won't be connected to the internet. You can make a subnet a public subnet by adding a route in your subnet route table to an internet gateway to support inbound and outbound access to the public internet. On the other hand, private subnet does not have a route to an internet gateway in the subnet route table. Also note that most architectures allocate significantly more IP addresses available for private subnets than for public subnets.
Okay. Routing tables. Okay.
Amazon Virtual Private Cloud VPC. Network Access Control Lists and Security Groups. First, let's look at Network Access Control List. A Network Access Control List is the firewall of the subnet boundary. Your VPC automatically comes with a modifiable, default network ACL. The default network ACL allows all outbound and inbound traffic. You can also create a custom network ACL and associate it with a subnet. Each custom network ACL denies all inbound and outbound traffic until allow rules are added. You can associate multiple subnets to a network ACL, but only one network ACL can be associated with a subnet at a time. Network ACLs are stateless and require explicit rules for both inbound and outbound traffic. It contains a numbered list of rules. Rules are evaluated in order, starting with the lowest numbered rule, representing the highest priority, to determine whether traffic is allowed or not. As soon as the traffic matches the rule, the allow or deny rule is applied, and evaluation ends. You can configure allow or deny rules to restrict traffic, based on the type of traffic, protocol, port range and source of traffic. On the other hand, Security Group acts as a virtual firewall, at the instance level to control inbound and outbound traffic. By default, a security group denies all inbound traffic, and allows all outbound traffic. When you create a new security group, you can define allow rules, to control incoming and outgoing traffic that is allowed to reach the instance. There is no deny rules required, because by default, it denies all inbound traffic. Security groups are stateful. Responses to inbound traffic are automatically allowed to flow out of the instance. Unlike NOCL, all rules of a security group are evaluated before deciding whether to allow traffic. Traffic can be restricted by traffic type, IP protocol, port range, and traffic source. Now, let's look at how you can chain security groups together to control traffic in this example. Most organizations create security groups with inbound rules for each functional tier. For example, in this architecture, we have web tier security group, application security group, and database security group in each tier. The inbound rule of the web tier security group allows internet traffic from anywhere on HTTPS port 443. At the application tier, the inbound rule of the application security group only allows traffic from the web tier security group on HTTP port 80. In other words, it can only accept inbound traffic from the web server, but nowhere else. At the data tier, the inbound rule of the database security group only allows traffic from the application security group on TCP port 3306 and nowhere else. By chaining the security groups together, you can strictly control the flow of traffic from the top tier to the database. Even if someone were to hijack the web server somehow, they still would not be able to access the database directly.
Hold on. All right. Okay. Again, just trying to do some multitasking. Got a lot of crazy things coming up in the next couple of weeks. So we're just finalizing that. All right. So we did the VPC overview and we covered the Amazon. So let's go ahead and see what they're talking about here. So we're going to review and change VPC network configurations to fix a connection issue. Okay. So here it talks about solution uses a common network architectural configuration that allows only internet traffic to reach publicly exposed AWS resources. So you see here, so we have our internet, we have our gateway, it gets to our router, and then from our router it goes to 10.10.0.0/24 network for the web server. And then there is a 10.10.2.0/24 for the database server. So these are the two networks, okay? So we're going to explore components that comprise of a virtual cloud, virtual private cloud, or a VPC. We're going to configure a route table attached to the subnet. We're going to configure an internet gateway. And then we're going to configure inbound rules within a security group. And then after that, for the do-it-yourself, we're going to change the security group rules to allow traffic over port 3306 into the database server. Okay, so we're going to start with the practice, see if there's any lab files. There aren't any lab files. We'll go ahead and start our lab and open up our console. And then we will share our console. And again, we just want to confirm that we are in the right area. So we are in US East 1. So we're in the right region. And then we go and make sure we're in the proper AWS lab environment and not our own environment. All right, so we're going to review that. Okay, cool. So we're done. Sorry. All right. So now we need to go to EC2. So again, we're supposed to search for it, but since we've already visited it once before, we can hit the recently visited. And then we're going to go into our instances tab over here on the left, and you'll see there should be there's two instances running. One should be the web server, and then the other is our DB server. So we'll go ahead and click the details. No, okay, so we'll click the details of this here, of our DB server. So you'll see we have the IP addresses, and we just want to, I guess we're waiting to get the public IP address. Though actually, I'm sorry, we shouldn't get the public IP address because that's a database, that's internal. We need to get the public IP address of our web server. So that's this one. So we're going to go ahead and copy that. And then we'll go into a new browser and we'll just paste it, see if it comes up. We'll share over here so you can just see. It's taking a second to load. I don't think it's going to load since it's lagging. It's either laggy or it's not working, which would go into our challenge. And when we go and check it, yep, it is not, site cannot be reached. So we'll go back to our AWS console. And we'll go back to our instances, which we are at right now. And now we'll go ahead and check the box for the web server. And we're going to click the networking tab. It says again, we're going to review the public and private. So we have our public IP address here, which is the one we copied before. That didn't work. But then our private is 10.10.0.10. Then here over here, you have our VPC ID. All right, so now we're going to go under the subnet ID and we're going to click that ID. So let's go ahead and click that. Looks like it opened up a new tab. So I'll share that new tab over here. And now we want to make sure we check it so we can see the details. Let's just bring this up a little bit since there's not really anything in there. And we're going to check out the routing table. So first, let's just check that information again. So we have our subnet ID. There is 250 available IP addresses. We are still in the US East availability zone. The availability zone ID is US1AZ4. Again, we have a CIDR range of 10.10.0.0/24 network. So we have all that information. So let's go ahead now and check out the routing table. I said check out the routing table, subnets. Sorry, routing table. No. Network. Here we go. Bring this up. Yeah, okay. No, we were right. Subnet routing table. All right. So now in the routing table, we're going to choose the box that's going to select for our routing table concepts. So that'll be this one, this NAT here. So we'll just click that. And now it brings up our NAT concepts. And now we want to check and we want to edit. All right, so we can go here. I don't know. I don't think that's what we want to do. We want to go route tables. What is happening? Okay, route tables, VP network concepts, VPC. Web server. So we'll go ahead and check that. No, how about this one? What the heck? Why does it keep bringing me back? Oh, because I'm looking at the wrong tab. My fault, y'all. It opened up so many tabs. I got confused. All right, so we go to routes, and now we should see this one. We'll hit edit routes. And we're going to go ahead and delete the NAT gateway. So we'll go here. And we want to click remove. Okay, so we left the local and we deleted the NAT gateway. And now we want to go ahead and add another one. So we'll go here, we'll add a route. For this, we'll type in, well, we don't have to. It looks like it's already there in the drop down. And then we'll name it Internet Gateway. And then we are looking at the IGW, this one right here for network concepts. Okay. We're going to then save that. So now we updated our routes for the network concepts. Okay. And basically what we're doing is we created we added a route for internet gateway. And to do the reason why we're doing that is because one, we want to make sure we're providing a target for our VPC routing tables for internet routable traffic. And then the next thing we want to do is we want to perform network address translation for instances that have been assigned IPv4 addresses. Okay. And that's basically when you see network address translation, that's like when you get external IP address and how that translates to your internal IP address. So that's essentially what we were just setting up there. Okay. All right. So now we go to our routes tab and we're going to review the information again. So we'll go back to, so we see it here. And then we're going to go back to our instances. So let's go here. Hold on. Navigate to the instances page on the EC console, EC2 console. I mean, do we really need to, since it's really still over here, but for the sake of it, we'll follow suit. All right, because then we'll do that, and then we'll just go back to our instances. All right, fantastic. All right, so we're back at our instances page. And now when we click our instances, we're going to choose our web server again. And we're going to go to our security tab. And now you'll see we have the security group down here for a web server security group. We'll go ahead and click that. Brings us to the security page. And now we're going to edit our inbound rules. So we're here with our inbound rules. We're going to go ahead and click edit inbound rules. And as you see, it says security group has no inbound rules. So now we're going to set up like our firewall. So we're going to add a rule. So add a rule. And then we're going to create a rule for our HTTP protocols. We're going to find HTTP. And then what we want to do is we're going to create our stateful security group. So basically what's going to happen is if we send a request from the instance or from an instance, the response traffic for that request will be allowed to reach our instance regardless of the rule. Okay, responses to allowed inbound traffic will be allowed to leave the instance regardless of the outbound rule. So we're going to do that by choosing anywhere IPv4. And you see it's going to tell us rules with a source of 0000/0. Allow all IP addresses to access your instance, and that's fine. So we're going to save that rule. And now when we go back to our instances, we're going to go ahead and click our web server again. We're going to look up our networking tab, which is over here right next to security. And now we're going to click that IP address. And now if we look at it, you'll see it went through this time. Okay, so now it's checking for everything. And if you see here, it actually tells us that it cannot connect to our MySQL server on 3306. So that is going to bring us into the do-it-yourself challenge, where we're going to have to fix that. All right, so we need to have it talk to port 3306. So we'll go ahead and going to go back to our security group rules. All right, so we're here in security. We'll click it. Now we have the one rule here, and we want to add another rule because this is the rule we originally created. Oh, sorry, y'all can't see that because you're still looking at my other screen. My fault. Almost did the challenge without showing y'all. So we're gonna go ahead and edit our inbound rules again. We're gonna add a rule. This one is for MS SQL. Nope, not MS SQL. What is 3306? Hold on. I forgot what service. Yeah, MySQL. Okay, so not MS SQL, MySQL. I'm about to say, I know there was a SQL service on 3306. MySQL, there we go, 3306. Right, and we are allowing, so we'll do anywhere IPv4. We'll save our rules. And now if we click check again on our website, it says no. Interesting. Double check the challenge. Change the security group rules to allow traffic over port 3306 into the database server. That's because we're still on the web server, y'all. My fault. All right, so we'll go back. We messed up, y'all. Or I messed up. I'm gonna take accountability. I'm not gonna blame y'all in there. So let's go ahead and we're going to delete. I just want to delete this rule. I don't want to delete. Okay, so delete the rule. We'll save it. And now we need to go back to our instances, go to our database server, click the security tab of our database server, go into the security group of our database server. We'll go to edit inbound rules. We'll add a rule. We're looking at port range 3306. And then again, that was MySQL. So MySQL Aurora. We'll do anywhere IPv4. We'll save that. And now if we go back to our instances again, don't see that. But now if you look over here, it's going to check. And we are connected. So in order to validate, we'll go back here to our challenge, and it's asking us for the database security group name. So the database security group name, we will copy, and now we will come over here, paste, hit validate. It's thinking. You created a rule that allows traffic from all IP ranges to your security group. This will work, but the rule is too broad. Create a rule that allows only security group web server security group to access port 3306 and try again. Okay, I thought so, but I figured that's what y'all wanted. So let's go back. We'll go back into our security group. We have our security group here, so we'll edit it. And we want to do it from the web server security group. You may not specify a reference group ID for an existing CIDR rule. Interesting. We'll do a custom TCP rule, and then we'll go to our web server. Create a rule. Okay. Let's think about this for a second. The challenge says, create a rule that allows only security group web server security group to access port 3306 and then try again. Okay, the web server using security group needs to connect to the DB server using security group. Okay, so now let's go back. Let's go back here. Let's go back to our instances. Let's go back to our web server. Let's go back to security. Let's go Click the security group. Let's edit an inbound rule. Let's add a rule. We're going to say 3306. And then in our security group, we have that. And now let's save the rule. Right? Are we still, do we still have our connection? Okay, so we're still connected there. So now our security groups, our web server security group, ID, go back to Cloud Quest and hit validate again. From all ranges, that's what you, okay. So did I not do that right? Okay. Instances, web server, security group, edit. Let's try this. Let's try this one. I think I broke it. Mm, mm, okay. Let's go to our database server and our database server security group. And then we go in here. And then we'll edit the inbound rules. And we're going to edit from the web server. You may not specify a reference group ID for existing CIDR rules. But you also don't want to allow CIDR block. Okay. This is interesting because it says it's working, but it's not. Okay. We can't do that. Let's just delete the rule. Okay, let's start all over again. So we have an HTTP rule, right? And it was an anywhere rule. Okay, so we'll save that one. So we know we have that one. And now we'll go ahead and we'll edit the rules again. We'll add a rule. This one. MySQL 30. Okay. Cider blocks. Okay. All right. So now we have that. And now if we share the tab, what? I feel like I'm making matters worse. What's going on, Ty? All right. Let's back up a second. So this is wrong because we're in the wrong server. So that's wrong. Right? So that's wrong. So now let's go back to our instances. We'll go to our web server. We'll go here. And now our web server, we have it set up where we need to add. So we need to edit the inbound rule and we need to get our HTTP inbound rule back. And now we'll save that. And now we should be able to get back to our thing, right? So now you can't connect. Okay. So now let's go back here. So we need to do our outbound rules. Let's edit an outbound rule. Let's add an outbound rule for MySQL, which is on port 3306. And we want it to go to the database server. And now we're going to save that. And then we need to go back to the database server for the inbound rule to accept from, right? So now we go back to our instances. Now we go back to our database server. We'll go to security. Security group, inbound, outbound. We don't want to allow all outbound traffic. So we'll delete that. Our inbound rule It's taking too long. Okay. 10.10 can't connect to the MySQL server. All right. So our inbound. What am I doing wrong? 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 All right, let's delete that. So we have an inbound rule to allow, right? And that's our database server. We are in our database server, port 3306. We are accepting inbound rules. All right, so we go back to our EC2 dashboard, go back to our instances, go to our web server. And then in our web server, we're going to go here and go into our security groups. That's wrong. So we'll delete that. Save. Outbound rules. Delete that. Why is it being okay? What am I missing? 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 I'm outbound needs to go. I'm about to cheat, y'all. No, I'm messing with you. Database server, security groups, edit inbound rules. So we have our inbound rule to allow stuff coming. Oof. Web server group. Outbound rules. You need to go from you need to allow 3306 coming from the web server. You need to allow 3306. Okay. So you need to allow coming in from the internet, and then you need to go out to 3306. Okay. I think that's right. Now from the database server, our inbound rule needs to allow from the web server, right? right, so now if we go here, and now we share the tab. Okay, so now it's connected. So let's not break anything. So now it wants us to give the database security group name. So we'll go back to EC2, go back to our instances, go to our database server, go to security, copy, go here, paste, validate. There we go. Thank you. So it looks like I had too many rules on the database server. So first they were in the wrong places, and then there were too many rules, and then I just needed to get rid of the outbound rule for the database server to make sure it was coming into the right port from the web server. And then from the web server side of things, we needed to make sure that it was accepting stuff from the internet. Right, so that's what this basically this allow all IPv4, and then the outbound was that it was sending the traffic to 3306. Okay, so all right, so that was just dumb on my part, but we got it figured out. So at least we figured it out. So we have completed the mission. Now it says we can build a city hall. I'll go with option 1 for my city hall. No. Yeah, I'll go with option 1 for my city hall. And now we are level 7. Okay. We've reached the level 4. All right. All right, cool. I just want to see what this one is. Chief Marketing Officer. Okay, how can I be of service? We wanted a logical isolation of our applications. So we set up separate VPCs for our marketing, development, and finance departments. However, all departments depend on getting reports from finance. Due to the isolated VPCs, the team members in marketing and development need to raise tickets to gain access to finance reports, which reduces our productivity. Okay, Amazon VPC offers VPC pairing. After you create a pairing connection, you can route traffic. Okay. Sure. Can I pair one VPC to multiple? Yes. But pairing connections are not transitive. This means you can create pairing connections from marketing to finance and development to finance, and no traffic is allowed between marketing and development unless you create another pairing between them. So basically, they're saying there's no transitive trust. So if you remember, if you're familiar with Active Directory, they'll have transitive trust between domains where if A trusts B and B plus B, and then transitive is like where if A trusts B, domain A will trust domain B trusts domain C, and then they'll say, well, then because of that, then domain A should be able to trust domain C. AWS is saying we don't do that. So you can have A trust B and B trust C, but they won't trust each other unless specifically told to. So A won't just trust C. All right, let's see. So it looks like it's just kind of VPC stuff again. We've done that. So now it says the solution uses several separate VPCs for each department. Okay, so you have marketing, finance, developer, and then you have your routing tables, right? Okay. The finance VPC is central, containing resources that are shared, okay, between the marketing and developer. Because VPCs are isolated by default, two VPC peering connections are created, one between marketing and finance and one between the developer and finance. Okay, so we need to look at this video in a second. Actually, let's just go ahead.
Amazon Virtual Private Cloud, VPC, peering connections. A VPC peering connection is a networking connection between two VPCs. This connection enables you to route traffic between your VPCs using private IPv4 addresses or private IPv6 addresses. In this way, instances in either VPC can communicate with each other, as if they were on the same network. When creating peering connections, you aren't just limited to your own VPCs in your account, you can peer with VPCs located in different AWS accounts. Moreover, the VPCs can be in different regions, also known as an inter-region VPC peering connection. With this in mind, VPC peering provides a simple and cost-effective way to share resources between regions or accounts. Additionally, VPC peering connections help facilitate the transfer of data. This can be used in a variety of scenarios such as replication of data for data redundancy, or to promote communication within organizations with uses like a file sharing network. When creating peering connections, AWS uses the existing infrastructure of a VPC. It is neither a gateway nor a VPN connection, and does not rely on a separate piece of physical hardware. As a result, peering connections prevent problems such as a single point of failure for communication or bandwidth bottlenecks. Peering connections also use the AWS backbone. Since traffic always stays on the global AWS backbone and never traverses the public internet, VPC peering effectively reduces threats, such as common exploits and DDoS attacks. Next, we will examine how to establish a VPC peering connection between two VPCs. The first VPC will be our requester, and the second will be our acceptor. To establish a VPC peering connection, you do the following. First, the owner of the requester VPC sends a request to the owner of the acceptor VPC to create the VPC peering connection. Before we continue with the steps, it's important to note that VPC peering doesn't support all configurations. For example, the acceptor VPC cannot have a CIDR block that overlaps with the requester VPC CIDR block. For the second step, the owner of the acceptor VPC, which is either you or another AWS account, accepts the VPC peering connection request to activate the VPC peering connection. The VPCs are now peered. Next, to enable the flow of traffic between the VPCs, the owner of each VPC in the peering connection must manually add a route to their desired VPC route tables. That route must point to the IP address range of the other peer VPC.
Got you.
Finally, if required, update the security group rules that are associated with your instance to ensure that traffic to and from the peer VPC is not restricted. Now that your VPCs are peered, you can go ahead and peer it with multiple other VPCs. However, note that VPC peering connections do not support transitive properties. All peered VPCs must be directly peered with each other. Similarly, VPC peering connections cannot use edge-to-edge routing to access resources it does not have direct access to, such as an S3 bucket.
Okay, so again, that's going to be helpful because it's basically telling us that you can create, you have it in each subnet. Why is it, did it stop?
Amazon Virtual Private Cloud, VPC.
Stop.
Amazon Virtual Private
Amazon Virtual Private must be directly peered with each other.
Okay, let's try that again. So to establish a connection, they can't overlap. So the IP addresses can't overlap each other. We talked about them not being transitive before. You need to update the route tables to add that IP network. So again, here you see the requester is 10.0.10 and the public subnet or the acceptor is 172.31.10. So they need to be each route needs to be added to their route tables, and then you need to add if there's anything in the security groups that need to be updated. Okay, that's good to know because I'm pretty sure that's gonna come up. Why are we back here? What happened? Oh, I think the game is glitching on us, y'all. Let me refresh it. All right, we're back to Cloud Isle. I guess we have to find that mission again. Oh, here we go. All right, so we talked about that. We went through there, watched that video. Okay, a VPC pairing connection is a network connection between two VPCs. We talked about that. Route tables need to be added. Okay. Access to finance VPC, the marketing VPC to route table. Appreciate you. Pairing. Oh, real quick, just an update. We are doing the AWS Cloud Quest. I guess we're jumping into another mission since I was being nosy. But we're going to create a pairing network, which is basically like a trust between VPCs. If you like what you're seeing, please go ahead and hit that thumbs up or like the video wherever it is you're watching, and also subscribe to the channel if you feel inclined to do so. Give me 1 second, y'all. See what's going on here. Hold on, y'all. Hold on. Sorry about that, y'all. Okay. So like I said, yeah, if you feel inclined to do so, please like, follow, subscribe. And then you could also up here in the top left-hand corner, you can support the stream by buying a coffee. It's $5, and everything goes back to building out continuing to build out our gaming and technology center that we have here in Swanee, Georgia. And if you are on our Alpha Cybersecurity page, which I believe a few of you are, you could also click that super chat. Again, it's not necessary, it's not mandatory, but it is greatly appreciated. All right, so let's get back to this. So again, we're going to have to create peering between the financial services to the marketing server, and then another one from the financial services to the developer VPC. So marketing server VPC to finance, and then from finance to developer. Okay, pairing is not transitive. So in this situation, the marketing server and the developer server will not connect. If this were, like I said, Active Directory, they would have something called transitive trust, where because marketing trusts finance, and because developer trusts finance, then marketing and finance could also trust each other and share resources. That's not the case here. You would have to probably create a separate peering connection for developer and marketing to communicate. Okay. All right. So we're going to connect both of those. So we'll go into the practice lab, and we're going to create the VPC peering connection, and we're going to ensure that the traffic is internally routed within the connection, and then we're going to create the one between the developer and finance. Okay, so it looks like we're going to do marketing to finance first, and then we'll do developer to finance for our do-it-yourself portion. So let's go ahead, jump into that. Again, make sure there aren't any lab files. We'll open up our console, and then we'll go ahead and share the console. Okay, and here we're going to search for a new one. So we're going to search for VPC, and we're going to click that. And then the next thing where it says here, we're going to look at our VPCs. So we'll click your VPCs over here in the corner. And as you can see, we have our developer, our marketing, and our finance. All right. And then the next thing we're going to do is go to our EC2s. And again, it says you can go up here and search. So we'll go ahead and just do that. So we'll hit EC2, we'll head over there, and then we'll go to our EC2 dashboard. And we're going to look at our running instances. And it looks like our running instances are our same thing, our finance server, our marketing server, and our developer server. Okay. So now what we're going to do is since our finance server is the focal point, we're going to click that first. And then we're going to make sure we review the IP address, the public IP address, as well as the DNS information as well. And then we're also going to copy the private IP address. So we're going to copy that. We're going to look over, and then we're just going to kind of scroll down and look up some more information here. So we have our VPC ID, our subnet IDs. Okay, so let's get our subnet ID again. Where is it? Subnet ID is right here. Okay. So we have that information. Now it wants to look up the information for the marketing server. So we'll go ahead and check the box for marketing, and then we'll click up here for connect. That's going to bring up our session information. And then we're going to go to our session manager, and we're going to click connect. marketing server. I'm going to connect session manager and then click connect. There we go. So now we'll move over here. So now we are in our command terminal. And what we want to do is we want to ping the IP address that we saved earlier. So we'll ping, paste, and we should get some responses back, or we shouldn't. So essentially it's just going to hang. So we'll just hit Control and C to cancel. And now we'll need to go back to our marketing server and get our instance ID. So here we have our marketing server, and then we'll click the instance ID for the marketing server, which will bring up this information over here. And now we're going to go to the subnet ID of the marketing server, which is down here. Subnet ID. And we'll go ahead and click that for the subnet ID. And now we'll share that. And we'll click this, and then it should bring up our information here. And then we're going to go check out our routing table. From here, we'll click that, and it should bring up routes. And now you see we have it's allowing internet here, and then 10.10.0.0. Okay, so we have that information there. And we have this IGW target. So again, those will be our rules. So now let's go down to pairing connections. So if we go to our, right here, we'll hit pairing connections. Let's get some music. Now that we have our pairing connection, we click pairing connections. We don't have anything in there, but we're going to create one. So we'll go ahead and go to our pairing connections. We're going to create one, and we're going to call it marketing the finance. So we'll go marketing to finance, and we'll just spell it all out. Okay. And then the requester, remember the requester will be our marketing VPC. And we're going to review that is that 10.10 IP range, which it is. Let me scroll down a little bit. And now we want to make sure that our acceptor is our finance, right? That's what we looked at before. So finance acceptor, we want to make sure that the IP address again is 172.31. So remember when we went to ping from before, it wouldn't allow us because there was no connection, right? And now we can just go ahead and create that pairing connection. Now you said it should be successful. And then if we go to actions, we should go ahead and accept this request. So again, it says, you sure you want to accept the pairing connection from marketing to finance? It's giving us the information of the requester VPC versus the acceptor VPC, the IP address of the requester, and then all of the other information. We're going to go ahead and hit accept. And then once we do that, there should be a pop-up box, which we went ahead and did that already. Now we have the success alert, and it should tell us that it's active down here, which it does. Now we'll go back to our instances menu. So we'll just go ahead and just type in EC2. Click that, go to our instances that are running. And again, we want to check out our marketing server. So we'll click marketing. And then we scroll down a little and we click our subnet ID. Let's move over to that. And now where we are here, we'll go ahead and check this for the subnet. And we're probably gonna have to update that route table. So we'll click route table. And then in the routes tab, we're gonna go ahead and edit routes. So we'll hit routes, so you see here, 10.10. Okay, now remember, we need to create routes for each one. So we'll go ahead and hit edit routes. And then we'll edit the route. We're going to configure the route for the destination. So we're gonna go ahead and add a route. And then for the added route, we're gonna find the 172 IP address. Actually, we're going to type that in 172 dot, what was that IP address? 31.0.0.31.0.0, and that was a /16 network. So we'll go ahead and do that, and then we will choose here for the peering connection, and then the PCX details. We'll just click that, and that's the one that we created. So if you look here, marketing to finance. So we went ahead and created that. And now we'll just go ahead, we'll confirm that all of that looks good. So that's our IP, that's our connection, that's the name of our connection that we created, and then we'll hit save changes. All right, so we saved that. So we should get our success message. And now we're going to return back to our instances. So we'll share this, close this out. And then we'll click the subnet ID again of the finance server. And we're going to do the same thing. So find our subnet ID. Click that. We'll share that. And you know, while we're here, since we know what the next thing is going to do, we're just going to try create that again for the developer to finance. Honestly. So we'll go ahead. We'll click this. Click the route table. Click it again. We're going to go ahead, go to routes, hit edit routes. Now we're going to do the same thing. We're going to add a route, and we need to get the IP address of the one. So that's 10.10.0.0. So 10.10.0.0/16. And then we're going to call, again, it's another pairing connection. And now this is the marketing to finance one again. That all looks good. We'll hit save changes. All right, that all looks good. That all looks good. Okay, we got our message that said it was successfully created. So now we'll go back to our EC2 instances. Now we're going to go back to our marketing server. So we'll get out of here. We're going to hit connect. Okay, and then we're going to click our session manager, and then we're going to come over here and we're going to share. Okay, and now we should get nothing. We don't get anything. What? Are you serious? Why aren't we getting anything? Wait. Would it be cheating if you ask a question for a hint? No, I don't think so, but I just noticed that my screen stopped sharing. So give me 1 second. I might have done something wrong. Let me get back to my screen share session. Okay, so now we hit connect. And now we move over here, and now we're going to share the tab instead. And then again, we're going to ping, paste. No, it's still not working. Now, why is that? It's not working because we have to we have to set up the, we have to set up, I know why it's not working. I know why it's not working. Let's go back. Let's go back. So actually, we're gonna deviate a little bit from the norm. We're going to come here. We're gonna share this tab instead. So what we're actually gonna do is, while we're here, before they have us running around all crazy, because I already know what we're gonna have to do. We're gonna have to set up the security group stuff. So before we do that, we know we're going from finance to marketing and then from finance to developer, right? So since we're doing that, let's hurry up and just do the finance to developer part. Let's just do that real quick. All right. Ty, how good are you in programming? And how do you stop comparing yourself on his hacking path or feeling less than? First question, how good am I at programming? I'm decent enough to know what I need to know, right? I'm not, I can't develop something, by scratch. I don't think most developers develop stuff by scratch like that anymore anyway. They probably have templates and things that they follow, and they also have things that resources that they use. That being said, I do. Yeah, Calvin, I think each department does need an access control list or a security group like we did previously. But I said, before we even go into the security groups, I'm just going to go ahead and create that other peer connection. So, but real quick to answer Ty's question. So yes, I know I have my, I know enough to understand what's going on. Truth be told, I am a little bit slower with doing reading or reading code or doing code reviews. Partially because I know that's something that I want to make sure that I'm doing properly. What's going on, Big Set? But yeah. Yeah, so I'm, like, for example, I just did a pen test, and it, it took me it took me a good few hours just to do the code review of the application. Just because, again, I wanted to make sure that, I was looking at everything. I checked all the libraries. I checked I wanted to, like I said, just wanted to make sure that, I dotted all my I's and crossed all my T's. So anyway, that's, I know enough to know what I need to do. And I also know where to find the certain resources. I see Calvin put something in there that said Watson X, right? Yeah, that's valid. Oh, sorry, I need to share this tab now. See, the thing I don't like is like it keeps on multiple tabs. So basically, I did that. I clicked the subnet. Then from the subnet, I went to the routing table, and now I'm going to go ahead and click the routes. Again, we're just doing the same thing that we did previously for the other two. So we're going to go ahead and we're going to edit the routes, and now we need to add one. Right. So we're going to go ahead and add a route. And we need to get the IP address. Oh, actually, I need to back up. No, I mean Linux. Yeah, Linux scripting is definitely a form of programming, but when you get into when you get into the weeds of programming, that's where with libraries and things like that, that's where it gets a little wonky for me. And then, like I said, and then understanding the different languages, right? So going, Python, or you're looking at Python, which is fine, JavaScript, whatever. Now you have Go and Rust and all these other things. So it's like you want to make sure you're. I just take my time when doing it, right? Like anytime I have a mobile app or some type of application pen test that requires a code review, I try to make sure that either they agree to giving me more time, not necessarily giving me more time, but making sure that there's enough time in the pen test to allot for that. All right, so we're going to stop sharing that screen, and now I'm going to. Oh, Ty, again, I said I know enough about programming to understand what's going on, right? So to answer the first part of your question, I know enough about programming or I know where to look. Calvin just talked about looking at Watson X or Python or Solidity and things like that. So like I said, I know where to look for certain things. That being said, I take my time because I know that that's not a strong point. And I don't try to hide it. I don't try to, pretend like it's not. And I let it be known, right? I tell them when I'm doing a pen test, like, look, yeah, okay, is there a code review? Okay, cool. So just understand that, I'll probably spend the better part of a day, depending on the size of the application, I should say. If it's a small app, there's no way in hell I'm going to do, there's no way I'm going to spend a whole day on a small application. But if it's a decent size app that has a lot of different libraries and, things like that, yeah, I'm going to take my time to make sure I'm looking at everything. Sometimes what I'll do is like when I worked for another AppSec job for a crypto company, what I had actually did to better understand what was happening was I actually did a side-by-side with the code and the app. So I knew what was happening at every step. Like I mapped it out, right? Like I took that chunk of code and screenshotted it and put it here to what it to show what it was doing in the app. But that's that's when you're like an internal team, so you don't have to worry about deadlines and stuff like that. But anyway, so that's the first part. The second part about comparing myself. I mean, at some point, I guess for me, I guess I'm just kind of real with myself, right? Like there are people who are way better at certain parts of pen testing than I am, right? Like I'm not the best. I don't do the best with like phone social engineering, right? I don't do the best there. But at the same time, there aren't too many people who can probably do physical pen testing as well as I do, right? I might not be the best pen tester in Active Directory, but there aren't too many. I don't think, but I definitely know I'm on top of my game with most web app or API testing. So, you just got to, again, know where you are, know your limits, and, whatever it is you want to work on, you take the time to work on it. You know what I'm saying? Like, there's not, like, as far as comparing myself to other people, in the beginning, I would compare myself to people who I felt may have been peers, right? So I might look at people who I feel like we might be on the same boat, and then look at it like, well, how are they doing this or how are they doing that? But I would also use that as motivation. You know what I'm saying? So Cover 6, that's what I'm saying. Cover 6 does cover AD analysis. Like I said, I mean, I can go over Active Directory pen testing time and time again, and I'm still not, like I said, I still don't think I'm the strongest at it. I can do what needs to get done, right? But as far as like knowing it like the back of my hand, one, there aren't too many people who do know it like the back of their hand, because again, there's always something going on. There's always new things that's happening in Active Directory, right? Some people might know how to do a silver or a golden ticket or a pass the hash attack or whatever the case may be, but they don't necessarily know everything. But guess what? That's what the resources are for. We talked about it offline where there's mind maps out there. I don't hide it. Shout out to Mayfly. Yeah, shout out to Mayfly, because that's the one who also created the game of Active Directory VM. But Mayfly had a mind map. They probably still do, but they have a mind map that walks you through an Active Directory pen test. And my very first Active Directory pen test that I did in how many years, I needed a refresher, right? Like I was in the web app space for like 6 years straight. I did not have to do an Active Directory pen test. I didn't have to do a network pen test. All right, it was all web app. I was strictly doing web app, and then after I did web app, I went into to mobile apps and APIs. I didn't have to touch it, and then so all these years later, I come in and it's like, hey, we need you to do this Active Directory pen test, and it was like, holy crap. And again, I told them, hey, I'm not that great at it, but they were like, hey, look, it doesn't basically, it was like, we don't care. Right? We don't care. It needs to get done. The client is paying us to do it, so figure it out. And that's what I did. I started looking for resources. I created a lab, started practicing on the lab, started remembering the tools, started researching the new tools since how many years from the last the last pen test that I did, and it was just like, okay, now what, right? And then from there, it was like, all right, cool. We did that and found that I had my tools that I knew I wanted to use. I had my my mind map that I wanted to, that I used for resources, and that's what I did, and I rocked the hell out of it. You know what I'm saying? Like I got domain admin. So yeah, and we've talked about this, you know, a lot over, you know, the course of our conversations. You don't have to know everything. You don't have to know everything there is to know about pen testing. And if someone tells you that they know everything there is to know about pen testing, they're lying to you, right? They can know what it entails. They can know, you know, they can know some of the tools that you're going to use as far as, you know, for recon, right? Like, for example, everybody's going to use, everybody's going to, you know, use some type of, you know, network map. So that somebody's going to use, you know, there's going to be a map involved, going to be some type of port scanner involved. You may have a vulnerability scanner or something like that can assist you. If not, you may use Nmaps scripts for vulnerability scanning. You may use OpenVAS just to help guide you, not to be your, you know, your primary resource. But, you know, you may use some type of vulnerability. So yeah, that stuff. Yeah, that stuff you'll probably have information on. But as far as someone telling you, oh yeah, I know everything there is to know about every type of pen test all the time, it's not, I'm not saying it's not possible, but it's just people aren't doing that all the time. And again, you have, like I said, there, you know, I hate to sound like that old guy, but it's like there are so many other resources now that there's so many other resources that weren't there when I started pen testing. You have Hack the Box, you have Try Hack Me. Calvin just said it again. He was weak in Python until he found Try Hack Me. But you know, there are so many resources there that, you know, just lab it out. Lab that shit out. You know what I'm saying? Like, there's no other way to, there's literally no other way to get comfortable without making yourself uncomfortable. Like, that's literally just the way it is. It is like, you're gonna have to step out of your comfort zone. You're gonna have to hit your head and fail. You're gonna have to do it. I mean, that's pretty much what we're doing here, right? Like, I haven't done AWS in how long, and I'm kind of refreshing myself on the labs. And like I said, I'm getting confused. You saw me here. I was just trying to figure out that firewall. That firewall took me however long it took me just to realize that I just put shit in the wrong place. So, you know, you can't allow yourself to you can't allow yourself to kind of just get caught up with what you don't know, right? If there's something you don't know, lock in and figure it out. Lock in and figure it out, or lock in and come to the conclusion that, you know what, hey, maybe it's maybe it's not what I was looking at, or maybe I underestimated. That's okay. That's okay. There's nothing wrong with that. No, but again, the knowledge gaps, like I said, the knowledge gaps are gonna be there. Guess what? You're gonna fit, and when you figure out the knowledge gaps are gonna be there, and when you figure out whatever it is you're struggling with, guess what? There's gonna be another knowledge gap. There's gonna be another. There's gonna be something else that's gonna be like, crap. I don't fully understand this. So rather than, what I'm saying, rather than just looking at it like that, it's like, all right, cool. Well, it is what it is. Let me lock in. Like I said, and again, it's uncomfortable. It's uncomfortable, and sometimes downright embarrassing. I mean, especially, look at me when I'm right here streaming. Like, it's embarrassing sometimes, to do it, but understand that it's the process. You know what I'm saying? Like, you got to put whatever it is, whatever you're feeling, whether it's ego, whether it's, you're just overly confident, or you just, whatever the case may be, like, ain't shit you could do about it. You gotta just, you know what I'm saying? You just gotta lock in. I need the finance IP address. .10.10.0.0. Oh no, yeah, I did what already. 10.10.0.0/16, and then that is for the peering connection. So again, if you just got sidetracked, we're just gonna go ahead and create that peering connection. Let's go back here. 10.10.0.0. Can we create multiple then? You're telling me it already exists. This is what happens when you jump ahead. Nah, no problem, man. Like I said, it's just, again, it's just the way things are, man. Like, which server are we in? Hold on. Let's double check this again. All right, so we did developer, right? So we'll click the developer, and then we'll click our subnet, and then we're gonna share the subnet tab, and then we're gonna come over here, we're gonna go to our routing table. Routing table, our routes, edit our routes. So this is our dev finance connection, right? Okay. Now let's go back to our EC2, right? We'll go back to our EC2, go to our instances, we go to our finance server, we click our subnet, right? And now we're going to share our subnets tab. We're going to go here. We're going to click our routing table. We're going to select our routing table. We're going to click routes. So now we have our 1010. Okay, so now we'll edit routes. And now we need to, okay, so that's what I did wrong. Okay, so that was a pairing connection for you. So now we need to create the pairing connection to the developer server, and the developer server's IP address was 192.168.0. So is that a 192.168.0.0? 192.168.0.0/16. And now we need to give it the peer connection of the dev finance. And now we're going to hit save. So now we have that created. So now we have this is the one going to finance to marketing, and this is going from finance to dev. And then if we go back to our VPCs, actually, let's refresh. Okay. All right, we'll come back here. We'll go back. EC2 instances. So we know we have we know our finance, we know we have the marketing set up, and now we'll just confirm again with the developer. So we'll do that by going here, clicking the subnet, sharing this tab. To click the subnet, go here, click our routing table, click the subnet ID, click the routing table. Are they playing tag? Okay. Routing table, come on. Routes, thank you. And now we hit edit routes. And this one is our dev finance, right? Yep, dev finance. Cool. All right, so we have all of our pair connections set up. So now we need to go back to our instances, right? And let's get back on track, because now we need to set up we try to do that. So now we're going to go to our finance and we're going to click security, and then we're going to open up our security groups, which is going to bring tab. Nope, that's our edit routes. Sorry. So now we have our security groups tab open. We're going to go to our inbound rules. And we're going to edit an inbound rule. And again, we are in our finance thing. So we're going to add 2 rules in our inbound rule. Okay? Because remember, we're doing both trusts or both peer connections. So we're going to go ahead. We added a rule. We're going to do a custom ICMP. So that will allow the ping. And then from the source type will be custom, and then we're going to do 10.10.0.0/16 for our CIDR block. And then we're going to hit save. Okay. And now if we go back over here, while we're at it, since we said that, right? So we're going to do another one for the, what was our IP address of the dev server? We'll do the dev server was 192.168.0.0/16. So we'll just create a second rule, right? We're going to edit another inbound rule. We're going to add that one, customize CMP 192.168.0.0/16. We'll just add both of them, right? And now if we go back to our connections, right? So let's go back to our instances. We'll share here, starting with marketing. We'll hit connect, open up a manager. We'll share this tab. And now, all right. And now we will ping, paste. And now you see we have the ICMP response, which means we have a connection between our peer connection. So we finished that. So now we'll share back over here. So we finished all of that, and now we got to we're going to come over here, and now it says to validate, we're going to verify the developer EC2 can communicate with the finance, and this will confirm VPC pairing. So we're going to configure that, and now we have to do we have to bring the instances of the developer and the instance of finance, right? So we're going to come over to here since we've already done that. Right, so our developer was our instance ID of our developer. We're going to copy, we're going to come over here. So our developer instance, and then we'll go back over here and go to our finance, and then our finance instance ID, and we'll come back over here. We'll paste, and now they're going to validate. And like I said, we did it a little backwards, or not backwards. We jumped ahead a little bit, but we have created our VPC pairing. And if we just wanted to double check, this is our marketing server, so we wouldn't be able to talk to our finance server for marketing. But if we just wanted to double check, actually, what is our developer server? 192.168. So we'll just copy that, and then we'll go to our finance server. I mean, we could have went to either one, but we could do that, and then we'll connect to a session just to confirm. And then again, we will ping, and then we will paste the IP address of our developer server. And that didn't work. Why didn't that work? Developer to finance, right? Let's try it the other way around. Oh, because the developer was the requester, right? That's how we did it. So let's try that way. Let's try that way. And I know y'all see me again. I'm going to share that screen over. All right, so the developer, I'm going to click that, connect. I need the IP address of the finance server. There you go. Oh, y'all not looking. There. So as you can see, the developer, because the developer is the requester and the financer is the acceptor. So developer has to be the one. So there is our ping, and you can see we have our connection. So we successfully created pair connections between our developer and finance server and our finance and marketing server. Now, if we wanted to, we could create another pair connection between developer and marketing, but I think y'all get the point. So with that, we're going to go ahead and wrap that up, because I think we've done enough testing. We need to go collect our reward. I'm gonna go with this little skyscraper here because I think it looks fancy. So again, our city is building up to look really nice. What's going on, L Style? All right, so now we leveled up again. So now we are level 9. And now we have a builder level of level 5. Our neighborhood's now at level 3. So now we have more customizations. So we actually just did two modules today. So if we go and check our progress, we've done, geez, we're not even halfway there. That's the crazy part for recertifying. But like I said, we knocked out a bunch of the stuff today. I'm just looking to see. So we need 7 more assignments. We have 7 more to go. So we did, like I said, we did 2. And now looks like, so we did, only things we have not done. We haven't done, I feel like I've done more than, oh no, that's because I was doing those quizzes. So we still have cloud economics, databases and practice, core security concepts, high available web applications, auto healing, file systems in the cloud, and first NoSQL database. So yeah, so it looks like we got, a chunk of stuff to get done, but we're making progress. So, all right. So like I said, so I'm going to call it here for the night. Cool. How many hours of training? I want to say it, honestly, if you figure, it's probably maybe about 12 hours. I mean, it's got to be something like that. 12, maybe 12, 13 hours. And see, Calvin, if you're still here, okay, so recertification island. That's interesting. So I'm on Cloud Isle, but then there's Security Island, there's Data Analytics Island, there's a Networking Island, Serverless Land Island, Generative AI, Machine Learning. This is my island, and then there's the Recertification Island. So I'm wondering, where's the map? Hold on. I didn't even know you could do it. Look, so see, this is what I'm saying. So they got little games in here, your little mini games. Go ahead and capture a drone. Oh, all right. So you have the which AWS service provides resizable compatibility, compute capacity in the cloud designed to help developers with web scale computing. Compute capacity, that's going to be EC2. All right. So we have come on, let me turn around. VPCs can be peered across AWS regions. I'm going to go ahead and say true. Hold on. Success connecting VPCs. They're elected. Okay, but oh wow, this is a challenge. Fill in the missing architecture components. The marketing firm has VPCs in 2 separate AWS accounts. They would like the EC2 incidents to set these VPCs to communicate. Okay. Oh, so I can't do that until I actually have to find the cards to. So that's what the cards are for. Got you. Because I was gonna say, because you need to set up. I don't own the VPC card either. Okay, so yeah. Okay, so you need to do that. Blue team perspective. What are your thoughts on Microsoft Sentinel? Everything helps, right? That's my first. That's going to be my first. My first thought is everything. Everything helps. You're going to self-study into Microsoft Sentinel. I would. I mean, it doesn't hurt, especially if you're in a mic. If you're good, if you plan on being in like a Microsoft shop or something like that. I mean, you never know what. You never know who has what, and again, it's good. It's good to have those things on your resume. So I wouldn't, if you know that's where you're gonna, you know what I'm saying? If you know that's where you're gonna be headed, I would, like I said, I mean, my thing is after I recertify this, I mean, I have my stuff with my gaming and AI and machine learning and stuff like that. But I'm gonna go. I'm doing another deep dive back into the AppSec stuff. I was supposed to start the AppSec rabbit hole program. Last month and a half ago, but it just didn't pan out that way. The thing about starting a business and kind of being everything and everywhere at once, the time just didn't permit for it. Plans that I had originally, things that were promised originally, just didn't work out like they were supposed to, and I ended up I had to pivot. So my goal is, once I finish this will help build up the algorithm to get back into get back into it, and also get me back into it, because again, streaming and doing this, while it's not easy. Hold on. AWS management console is recommended for uploading files larger than. Sure. Oh no! Don't run away. So yeah. Oh man, he not letting me go by. Okay, which key value pair can be used to describe EC2 instance in the custom content and metadata? Tags. There we go. Yeah. So I mean, I'm getting back into the whole thing. I'm talking web, mobile, API, IoT, smart device, like the whole nine. And then, then cloud, and then AI. So do I plan on getting back into the full-time workforce? Who knows? We'll see how the business does. But again, I still think it's something that's good to know. When will I go back to my channel for interviewing? You mean like InfoSec Unplugged? My goal is to be back doing InfoSec Unplugged soon, by the fall, sometime in the fall. Slowly making the strides, or making the moves to have everything set up to do it here. Yeah, so InfoSec Unplugged. I don't know if you can hear me knocking on wood, but InfoSec Unplugged should be or will be back in the fall. What are you talking about? I feel like I'd be answering the. Okay, me, whatever. I gotta review it. I feel like I know, and this is what I'm saying earlier. Like I answered the question, but then when I watched the video again, it said that was that I did have the right answer. So I don't know. All right, but like I said, I'm gonna go ahead and I'm gonna call it a night. It's kind of slow here today, so I might just wrap up and head home a little early. But I should be back on, if not early in the afternoon tomorrow. I'll be back on Wednesday. All right, I got classes and stuff tomorrow. So in the evening, so I won't be able to stream in the evening time. So we'll see how the day goes tomorrow. And if that pans out, then I'll do that. So, all right, y'all. Well, y'all go ahead and y'all enjoy the rest of your Monday. And like I said, I'm gonna probably hang out for a little bit longer, and then I'm gonna close up shop myself and head to get some dinner. All right. Peace out.